We already proved a very similar theorem about residue systems, and in this theorem we want to show that same thing happens for reduced residue system. Okay, so let's say R1 through R phi of n is a reduced residue system modulo n, and condition is A is positive integer which is relatively prime with n, right? Then this new set AR1, AR2 up to AR phi of n is also another reduced residue system modulo n. So actually we need to prove two things. The first part should be they are the kind of residues, right? Okay, reduced one, and second part is none of them are congruent to each other. Okay, that's the we need to prove. So first, let's say one of these, and it's one of these is not relative prime with n. Okay? Because to become a reduced residue system, by the definition, all of them are relative prime with 1, right? So we don't know relative prime with n, right? So we don't know that one, so we need to prove it. So let's assume one of them is not. So one of them is not relative prime with n, which means the greatest common divisor of these two numbers for certain arj should be greater than 1. Then there must be a prime divisor p for both, right? So p is a divisor of arj and n at the same time. Then from the first one, like okay, so p is a divisor of a, or p is a divisor of rj, because p is a divisor of a times rj, and since p is a prime number, it should be a divisor of a or r of j, maybe sometimes both of them. So the meaning is p must be a divisor of a and divisor of n at the same time, or p is a divisor of rj and divisor of n, okay, in two cases. But it cannot be the second case, because rj is a member of this reduced residue system, so which means p is not cannot be a divisor of that, right? Okay, and like both p is a divisor of a and p is a divisor of n at the same time, right? Because a and n's are relative prime, and therefore arj and n must be relative prime for any j. So it should be small j here, right? So 1 through this, so which means any of these, any integer in this set must be a relative prime with n. That's clear. And second part is very simple. Let's say any two elements in the set, okay, is congruent modulo n, because we need to prove they are residue system, right? So none of them are congruent for modulo n, but let's assume there are certain two integers in there are relative prime. Then the meaning is because a and n's are relative prime, you can cancel out this a, okay, from both equation. Then this one claims rj is congruent to rk modulo n, and that is contradiction to this, right? Okay, we already have that condition. So altogether, it's clear that AR1 through AR phi of n must be another reduced residue system.